All right, thanks, Beth, and thanks, Dan, for that setup and everything. I'm going to dive right in. In terms of framing a discussion here on climate change impacts on water resources in the Great Lakes region, there's far more that we can intend to cover here in 10 minutes. But I want to frame the discussion here in a three-pronged approach, and those three prongs include, if I can find the right arrow here, changes in water quantity, water quality, and then most importantly, how systematic changes in water quantity and water quality change what we have come to expect from those resources. And that's sort of really what ties us all together. So there are far too many examples of how climate change are impacting water quantity and water quality. We've seen many of them already. One of the more profound ones in terms of water quantity are changes not just in the magnitude of precipitation or evaporation, but also in the timing of the seasonal cycle. And Dan underscored some of those changes as well. This particular image captures a lot of that. This is a picture of Niagara Falls. And I show this picture because Niagara Falls represent the largest hydropower facility in the state of New York. And the managers at the New York Power Authority and Ontario Power Generation rely on accurate historical data of the seasonal water budget and accurate projections of the seasonal water budget in order to make very important management decisions about this massive resource. Another example that we saw earlier, to echo what Don was saying, is in 2011, one of the largest harmful algal blooms ever recorded occurred on Lake Erie. This image is taken from a recent paper in PNAS by Anna Mikulak and others. This particular phenomenon captures both changes in water quantity and water quality, synthesizing changes in the magnitude and the frequency of precipitation, as well as changes in temperature in the receiving waters and changes in land use. So yet another example. And then one last example I want to show that's been talked about quite a bit today has to do with phenomenon that are indirectly related to water resources, directly related to climate change. This particular slide shows both ice cover and surface water temperature on Lake Superior. So on the x-axis on the bottom there, you have years going from 1972 up until 2013. The blue vertical bars represent the amount of ice on Lake Superior in days after November 1st. Lighter colors indicate low concentrations of ice from an aerial spatial extent. Dark covers are aerial extent on a percentage close to 100%. So what you see are some pretty remarkable things. The red line at the bottom shows surface water temperature. And what you can see, has been talked about earlier, is there was a period where we expected a certain amount of ice cover and a certain surface water temperature, and there was quite a big shift that happened in the late 1990s, coincident with the El Nino event at that time. What I want to do is talk not only about how this changed the hydrologic regime of the system, but when we look again, I just added in the 2014 data for ice cover. And what you can see is that the aerial extent and the duration of ice for 2014 surpassed that from 1979 and surpassed that from 1977. And I've also included at the bottom a projection of what the year-long surface water temperature might be when the year comes to an end for Lake Superior. So one of the fundamental questions here is, will we end up in conditions that are closer to the pre-late 90s, or will we end up after this year reverting back to conditions similar to the last decade? A fundamental question from a water resources planning perspective. So all this points towards the idea that what we're trying to do in this region is conduct scientific research to improve understanding of these processes. And one of the best examples I can think of this that's going on right now is research that's being led by some very forward-thinking scientists. Dr. Peter Blanken of University of Colorado Boulder, Dr. Chris Spence from Environment Canada, and Dr. John Lenters, who's now here in Ann Arbor with Limnotech, were some of the first scientists to place eddy flux towers on top of old, abandoned lighthouses in the middle of the Great Lakes. This is the White Shoal Lighthouse, which is in the northern part of Lake Michigan, and it's one of 6 research sites that is currently helping us get direct measurements of over-lake evaporation. And I view this as an example of truly national-scale pioneering research to get an understanding of how climate change is having an impact on the Earth's largest freshwater surfaces. So what we try to do next, of course, in the region here is pull that data together or pull that research together and try to synthesize it in data and models to support important decisions. So shifting next, what are some of the sensitivities, what are some of the challenges and opportunities we have here? And I would argue, I would echo the previous panel, and I would argue that one of the greatest challenges we face when it comes to looking at water resources throughout the Great Lakes Basin is the quality and availability of information. And there's a lot of examples I could give for why that's a challenge, but one of them has to do with this perspective on freshwater basins. And you can see here in the upper middle of the screen, you can see in light blue is the Great Lakes St. Lawrence River Basin and other major river basins of North America. Now, that's a hydrological perspective on North America. Here's a political perspective where I overlay the boundary of the Midwest Regional Climate Center. And what I would propose to this group is that that boundary does not serve the interests of the water resources in the Great Lakes particularly well. We need paradigms, we need frameworks that look at the Great Lakes Basin holistically in order to address some of these major water resources management planning questions. So I've talked earlier about variability and uncertainty, and other panelists have as well, one of the major challenges we face here. But what I want to propose is a context here in which we try to reconcile that through improvements in data and models, but also improvements in understanding of interpretation of results. One of the things that NOAA has done, I think, well, is their work on hurricane forecasting. So this particular example of a hurricane forecast representing a cone of uncertainty encapsulates, I think, two important points. One is that there has been a significant improvement in the models that go behind this particular projection to make hurricane projections more accurate. Second, there has been essentially a campaign to get the general public to be able to interpret for themselves the information they need from this image to make their own decisions about whether or not to move, about whether or not to get on a plane or not get on a plane. And I think that's an important connection between the two aspects of what are behind this image. And I think it's something we can continue to adopt here in the Great Lakes region with the data and the models that we communicate. So third out of 4 bullet points here, one of the opportunities I think we have is to continue to develop and recognize products that are being developed that leverage investments that are already being made in models and data across the Great Lakes Basin. There are many people in this room who work on developing internationally coordinated models and data, and it's important to continue to promote those and develop products that get them out to end users. One of many examples of that I want to highlight is an effort that NOAA and Environment Canada have recently embarked on, which is a climate quarterly product. It parallels a product that was being developed in all the other regional climate centers throughout NOAA, and then what we've done is we've put that together in one that specifically targets the Great Lakes region from an international perspective, bringing to everybody the latest climate information available. I think it's a great example of how we can overcome some of the barriers that I highlighted earlier. And then last but not least, one of the other opportunities I want to underscore that has been talked about in the previous panel is the idea of adaptive management. And this is a term that is thrown around quite a bit in the water resources management industry. What I want to underscore is the fact that adaptive management has been officially proposed as a paradigm within which different parts of the International Joint Commission and regulatory boards of control in the Great Lakes operate. So there's actually an opportunity here that holds some specific promise. And with that, I will wrap things up and turn it over to the next speaker.
30%, and I think if you ask Laura, you get around 8 to 10%, and the creek shed ecology really starts to suffer. So that's a whole nother issue with our creek.